is an important set of 5 numbers that we often will use to describe a distribution, and that is our 5-number summary. And for any set of observations, it is the numbers of the minimum value, the maximum value, your first and third quartiles, and the median. So it's those first and third quartiles and the median that we looked at, but we also add the minimum and the maximum. So just the smallest value and the largest value. What this 5-number summary can help us see is how symmetric our distribution is, where the central tendency of our distribution seems to lie, and an approximate variation or the variability in the data set. So we'll often use those 5 numbers in describing distributions, as well as creating a visual representation called a box plot. You may have also heard of this as a box and whisker plot, because there's a box and then there's little lines on both sides that look like whiskers. So it's a very compact graphical summary that provides a lot of really good information. You can see the 5-number summary from your box plot. Those are the values that are highlighted in a box plot. So in order to do a box plot, you need to make sure that you have your minimum, your maximum, your Q1, Q3, and median. We've already talked about how to get Q1 and Q3 and the median. The minimum and the max are easy. It's just literally the smallest value and the largest value in your distribution. We're going to draw a horizontal axis that represents the length of your observation, so your smallest and your largest. And then you'll sketch a box, and it can be of any height, just whatever makes sense for your data, that represents Q1 to Q3. So let me show you what this looks like. Here we make this box, we make this box here where Q1 and Q3 give us the starting and ending point of our box. Then you put a line that represents the median, and then you stretch your whisker from Q3 to the max and from Q1 down to the min. And so you can see the minimum, the Q1, the median, Q3, and the maximum represented in this box plot. You can also see that it seems to be centered around, this value, and it does seem to be slightly right skewed or positively skewed because this side is longer than the right side. So, depending on how much skew you have, then this is definitely a very skewed to the right box plot, but this one is a little more symmetric. So you can see this nice and visually. So it's really just a graphical representation of the 5-number summary. So this is an example of a systolic blood pressure data set, and we can see here that it is quite skewed to the left. And with the data, and this was data that you can download, you get the 5-number summary. The min was 67, Q1 was 135, the median was 163.5, Q3 was 180, and the max was 203. So those all got plotted. Notice that the x-axis goes from 60 to 200, a little bit further. That captures everything, and it is evenly spread out. So you want to have that spread out so that you can really see what's happening in your distribution. But from here, we can see that most of the values are there between about 140 and 180. And it is left skewed because this side of the graph is definitely longer than the other side. Now, in JUMP, the box plots tend to be vertical, but those can easily be changed to horizontal. And I prefer seeing them horizontal, but I know a lot of the graphic, the statistical software packages will draw them vertically. So let me just show you what that would look like in JUMP. Since I still have the Brooklyn Bridge data up, I'm just going to use it and analyze distribution and get that walk time over. And you'll see that this box plot came up automatically. Now, here's the bottom side, here's the top side, and I just find it a little hard to do that. So if I do horizontal layout, that'll switch it to horizontal, which makes it a little bit easier to see. And in JUMP, it is going to give you both the histogram and the box plot. And so here we can see that most of the times are between about 35 and 55. Okay, I'm getting that from that middle piece, the box. And we also see that it seems to be relatively symmetric, maybe a little left skewed, but it's more symmetric than skewed. So you can have that box plot, and then in your homework, if you're just trying to answer questions about skewness, it's fine what they're using here, but just know that the value for Q1, the median, and Q3 are slightly off in JUMP because it's using that higher, more sophisticated process of finding the quartiles. Another valuable thing about box plots is that we can actually use them to identify outliers. And so when you have your 5-number summary, so you have your quartiles, you have your median, and you can easily calculate your IQR by doing Q3 minus Q1. We can create what's called low and high inner fences and low and high outer fences for where we would identify outliers. So the inner fences are giving you where things would be slight outliers, and then your outer fences would be where you have extreme outliers. So to do this calculation, you just take your Q1 and go a little bit more to the left. So you would subtract 1.5 times the IQR, and you would subtract 3 times the IQR to get your inner and outer lower fence. And then for your upper fence, you'll start with Q3 and you will add 1.5 times the IQR for the inner, and then 3 times IQR to Q3 for the outer fence. Anything that falls in these fences is going to be outliers. So draw your horizontal axis and then figure out where these fences are going to be. And I usually just do like a dotted line through these, and I'll show you how I kind of work through these. And then you draw a whisker from Q1, but only to the smallest observation within the low inner fence. Okay, everything that's within that low inner fence would not be considered an outlier. Anything beyond that would be. And then we'll draw a whisker to the largest observation that's within the high inner fence. So your modified box plot, your max and your min are no longer necessarily your starting and stopping point. It's the smallest and largest points within your fences. Now, mild outliers are the ones that will fall between the inner and outer fences, and we plot those as shaded circles. And then extreme outliers are the ones that are further, that they're beyond the outer fence, so they're really far away, and they're open circles. So why do we do this? Well, remember that 99.7% of symmetric data is going to fall within 3 standard deviations. So anything that's beyond that is really, really extreme. Even for non-symmetrical data, we know from Chebyshev that if we go 3 standard deviations from the mean, then you are capturing like 89% of the data. Well, here we're not using standard deviation, we're using the interquartile range, but it's a similar concept here that, it's 3 interquartile ranges, which is kind of, it's just a different way of describing your variation. So let's see how we would do this. So I'm going to be using data from example 3.20, where we're looking at the length of sled dog trips. And this is how many hours these trips were. So we're going to go ahead and start, We're going to go ahead and start with the 5-number summary instead of worrying about getting that. Because here at this point, we've done it a few times. So we have Q1 is 1.1, our median is 2.6, our Q3 is 3.7, and our IQR, which is Q3 minus Q1, is 2.6. So let's find our inner fences. We take our Q1 and we subtract 1.5 times that interquartile range. Here, 1.1 minus 1.5 times 2.6, that is going to be at negative 2.8. And our inner fence, but on the high side, would be 3.7 plus 1.5 times 2.6. So 3.7 plus 1.5 times 2.6 gives us 7.6. Now for our outer fences, we're going to go 3 of those IQRs. So 1.1 minus 3 times 2.6, that's negative 6.7, and 3.7 plus 3 times 2.6 gets us to 11.5. Now, we want to look at any of the observations that are, beyond these inner fences. And since the inner fence on the low side is negative, we don't need to worry about any of those values. But with a 7.6, we may have some values that are outside of there. So let me draw this, and I can just start at 0. I'm really going to ignore those low fences because they're negatives. They don't make any sense here. Let's count by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I have to make this just a little bit smaller because I do need to go to 12. $11, $12, because my max value is 11.9. And so, we'll do our middle box like normal. So here's Q1, here's our median, here's our Q3. So we draw our box here. And our lowest value is 0.1. And so we don't have to worry about any fences on that side, but on this side, I do have a fence at 7.6 and a fence at 11.5. So my question now becomes, what is the largest value less than 7.6? And if you go through the value, I know you're going to have to look at this in the textbook, but the lowest value, or the highest value that's within this fence is actually 6.1. So my upper whisker is only going to go to 6.1, even though I have other values that are beyond this. There's a 7.9. So that's a minor outlier because it's within the fences. So I plot there at 7.9 and also at 9.5. But then 11.9 is even beyond this, and so it's going to get an open circle. So getting these outliers, you draw these fences and you figure out, all right, most of the data needs to be, within, between the fence values. So the hardest part is just figuring out where to stop your whisker, and it needs to be at the furthest point that's still within your, within the fences. So over here, I didn't have to adjust anything on the left because 0.1 was well within the lower fences. So those were into the negatives. I didn't have to worry about them. And so sometimes you will have to kind of go into that direction as well. But once you find your fences, here you're going to have your mild outliers, and then here you're going to have your extreme outliers. And the same thing would be happening on the other side if this particular example had low values. This graphic might help you kind of recognize what's going on. So you have your IQR, and then from Q1 and Q3, you go out 1.5 and 3 IQRs. And that's where you can see your mild outliers are between those fences and your extreme outliers are even beyond. One last thing is sometimes you will have multiple box plots, and these can be helpful because you can compare multiple distributions at the same time. And so here I could see that, whatever this gas station is, was going to have much lower prices, particularly compared to this one. There's some overlap between gas stations 1 and 2 and some overlap between gas stations 2 and 3, but the medians are very clearly different. The middle 50% are very clearly different. And then we also can see that gas station 1 and 2 had a few high outliers, but gas station 3 did not. You can also see that gas station 1 was, it's kind of hard to describe this one because it would be left skewed without that outlier. So that one's going to be a little bit tricky, but you can make comparisons to see which ones are skewed, which ones are symmetric, and so forth on those. So we like to see these stacked box plots because you can make comparisons of multiple distributions at once.